Hello, class. Welcome to our first lesson in Chapter 8. We kind of skipped over a few things that we'll come back to later on in the semester in Chapter 6 and 7. For now, I just want to look at one section of Chapter 8, which deals with polar coordinates and polar equations. When we're dealing with polar graphs and polar equations, there's some formulas that you want to make sure of, and probably have those written down, so we'll look at those and then go through a few example questions. Okay, the polar coordinate system is different than the normal coordinate system that you're used to. So you're used to kind of this crisscross x and y axis with x and y. So x would be left and right, y would be up and down. The problem with the rectangular, or what the Cartesian coordinate plane, the x and y plane, is the fact that if you have something that is circular or round or oval or anything like that, spiral, it's very hard to graph because it fails the vertical line test. So the polar coordinate system allows us to do that. Instead of x and y, we use r and theta. R represents the radius, so like how far out away from the center it is, and theta represents what angle or which spot you're looking at on the angle. Okay, here are all of the conversions that you want to know and the polar versus rectangular information. So we know that rectangular is always xy, and polar is always r comma theta now. Your conversions are these four. These are the only four things you can use the entire time during Chapter 8. X equals r cosine theta, and y equals r sine theta strictly comes from the x, y, and r from the very beginning of the year, where x over r equals cosine, we just multiply the r to the other side. Y over r is sine, move the r to the other side. The next one is just Pythagorean theorem. When we drew our triangles out, x squared plus y squared equals r squared. And tangent of theta would be the opposite over the adjacent. That's all that's saying. So these four things we've done before. It's just now we're consolidating them all in one spot. The first set of questions that you're going to look at will give you an equation and then just say figure out what r is. So it's basically just a plug and chug situation substitution. So if theta is 30 degrees, r equals 3 times cosine of 30. You just plug in 30 degrees for cosine. Everything that you're looking at in a lot of these questions should be exact values, so you want to make sure you practice that. So 30 degrees cosine is adjacent over hypotenuse, which is root 3 over 2. And then you just multiply by 3 and you get 3 root 3 over 2. And that's the radius then at that location. The next one, 8 sine of theta. So theta is 135. Sine in quadrant 2 is positive, and that's a 45-degree reference angle. And that's 1 over root 2 for opposite over hypotenuse, which is root 2 over 2. And then multiply by 8 to figure out that it's 8 root 2 over 2. But don't forget to simplify, so the 8 and 2 become just a 4 as you're looking at that question. Don't forget to simplify any of your questions as you're looking at those scenarios. Okay, the next one you'll notice has r squared. The only difference here is there's going to be two answers, one positive, one negative. Think about if it was x squared equals 9. When you square root it, you get plus or minus 3. Same idea here. Sine of 2 theta. Sometimes students think, oh, I got to change this to something else. Well, you can plug it right in. So 2 times 75 would be 150. 150 is a 30-degree reference because 180 minus 150 would be 30. Okay, and that reference angle, sine would be opposite over hypotenuse again, which would be 1 over 2, and then times 10 would be 5. Now that's not the answer though, you gotta make sure you square root it, and there should be two answers. In your homework stuff, I think you have to separate them with a comma, so you just make sure you have two answers in those locations with r squared. All right, there's a lot of information here because there's three parts to the question. This will be similar to what you see for your assignments. They'll give you a polar coordinate. So this polar coordinate is 2, 60 degrees, and they'll say plot the point. Okay, to plot the point, I tend to find the angle first. So here's our coordinate plane in polar graphing, excuse me. 60 degrees is the one right here. Okay, so this is 60. And then I go out 2, 1, 2. Okay, so out 2, that would be 60 degrees. And that's where the letter P, or the point P, excuse me, ends up. Give the rectangular coordinates of the point would strictly be plugging into x equals r cosine theta and y equals r sine theta. You just plug in 60 degrees for that, and you'll get 1 and root 3. That means in rectangular, it's 1 comma root 3 for your coordinate plane. So this would mean I went over to the right 1 and up root 3. That would get me to the same spot if I was using the x and y coordinate plane. The other thing is that there's more than one way to write the exact same point. That doesn't happen in rectangular because the graph for rectangular coordinates goes on forever in each direction. But because of the circular nature of the angle, it's possible that you have multiple answers for the same spot. So the point 260, think about it, if you're coterminal, if you go around again, okay, the easy one is just add 360. So that's why 2 and 420 work, because if you keep adding 360, you'll end up in the same location. The one that's a little strange is the negative 2, 240. And here's the idea. If I go 240, it should be in this direction towards 240. But if I say negative 2, I can't go its direction. I have to go in its opposite. So essentially, there's a line there. And instead of going 2 in the direction of 240, I go 2 in its opposite direction, which would put me up here at 60 in the exact same location as the point P. So when you're dealing with those scenarios, you just want to make sure that you're going in the direction positive. If it's or if the R value is positive, go in that direction. If it's negative, go in the opposite direction in order to find your answer. The next one is the 0.3 comma 2 pi over 3. Some of you might find it easier to change 2 pi over 3 into degrees by multiplying by 180 and dividing by pi. That'll be 120. Other option is pi over 3 is 60 times 2 is 120. Okay, so that's in 120 with a radius of 3, so 3 out from the center over here at 120. That's the point Q. You plug into x equals r cosine theta, y equals r sine theta. If you have trouble finding those answers, make sure you let me know or draw a reference triangle. Okay, you need to be able to find these answers here. Notice here that the x value is negative because you're going backwards. Think about it. If it's on a coordinate plane, it would be back so far and then up. So the x value should be negative. And then you want everything in radical format in these. These are all exact values, so they should be able to be found with your triangles or the unit circle ideas. Again, we could add 360 to this. Now, this is in radians, so your answers here had to be radians, but you could do it in degrees and just flip it around. You're essentially adding 360 to 120 or 2 pi to 2 pi over 3, and that'll give you 8 pi over 3. And then don't forget the other answer would be go the other direction for the angle, which would be 300 degrees, which corresponds to 5 pi over 3. But then your radius needs to be a negative. So there's a lot of pieces here to this question. Plot the point. The rectangular coordinates is just using the formulas that we were given earlier. And then the two pairs of polar coordinates that are the exact same. One should just be coterminal, add 360 or subtract 360. The other one probably is a negative angle, just going in the opposite way. What you'll notice here is in a line, it's basically add or subtract 180. Okay, if I want to be here and go to the other side, that's add or subtract 180. So 180 and 360 are the key to those questions. Okay, your homework should be available. Make sure you get to work on that. Pay attention to your equations. Make sure you have those written down for going between rectangular and polar coordinates. Have a good day.